Continuing on in section 2.3 here, we can use different methods to solve equations that contain fractions. Our first step is always not panic. Don't panic. Okay, first step is always to don't panic. So when we see fractions, we have two options. We can either work our equations the way that they are with fractions included, or we can clear our fractions. And that's the first way that I'm going to use here, is I'm going to get rid of our fractions. So when we do this, we can look at our fractions, compare our denominators. Right now I have a 4 and a 3. My least common multiple of those is 12. So if I want to, I can multiply both sides of my equation, every single term, by that common denominator of 12. Remember, whole numbers are over 1. So we're going to multiply straight across here. I'm going to get 36x over 4 minus 12x over 3 equals 120. Again, I multiplied by my least common multiple to every single term. Now I'm going to reduce if I can. 36 divided by 4 gives me 9x. 12 divided by 3 gives me 4x equals 120. Now I have no more fractions, and I can simplify both sides of my expressions. 5x equals 120 by combining my like terms. Now to move from one side to the other, I do the opposite. Opposite multiplication is division, my inverse there, and I get x equals 24. Now some of you are probably like, okay, but I don't know how you got that least common multiple. Okay, that's okay. If you're not 100% comfortable with the least common multiple, we can bypass that step and do each one of these individually. So instead of multiplying by that least common multiple, I can take each denominator and clear them one at a time. So right now I have a 4 in my denominator. Right now it's being divided. I get rid of division by multiplying. And I'm going to do that to every single term on both sides. Remember, whole numbers are over 1, so a 1 in my denominator, 4 over 1. We multiply fractions straight across. I have 12x over 4 minus 4x over 3 equals 40. Reduce if you can. So 12 divided by 4 is just 3x minus 4x over 3 equals 40. 4x over 3 doesn't reduce here, so I'm going to try and get rid of my dividing by 3. Right now I'm being divided by 3, so I'm going to multiply by 3. And again, I do that to every single term in my equations, both sides entirely. 3 times 3 is 9x, minus 3 is over 1, 12x over 3. We multiply straight across there. Reduce if we can. 12 divided by 3 is 4. And I get to 9x minus 4x equal to 120, the same way I did if I multiplied by my common denominator. And that's because here I multiplied by 4 and by 3, which really is 12, that least common multiple. So if you're not comfortable finding a common multiple to multiply by right away, we can clear each denominator one at a time. Because once we get to this step, it's just 9 minus 4x, which is 5x, and then divide to get rid of our multiplication, and x equals 24. Our second method here is to just work with these as fractions. Okay, we need to simplify the left side of our equation here. In order to do that, we have to have a common denominator. So between 4 and 3, my common denominator is 12. I'm going to get both of my fractions to be 12s. To go from 4 to 12, I have to multiply by 3. And whatever I do to the denominator, I've got to do to the numerator here. Because I'm only changing one term, I have to just multiply by 1. Otherwise, it changes the value there. And I'm not changing the value, I'm just rewriting it to look a little bit different. So 3 times 3 is 9x over 3 times 4 is 12. To go from 3 to 12, I had to multiply by 4. And again, I'm not changing the value, I'm just rewriting it to look a little bit different. So 4x over 12 is the exact same thing as x over 3, it's just not reduced. Now, again, I'm still just trying to simplify my expression here. I have a common denominator, so I keep my denominator and I can do my operations just on my numerator. 9x minus 4x is 5x. We look at what's happening to our variable now because both sides are as simple as we can get them. You can either look at this as being multiplied by a fraction or as two separate things. I'm being divided by 12, which I can get rid of by multiplying by 12. And I'm being multiplied by 5, which I can get rid of by dividing by 5. It's the same as if we'd have looked at this and been like, okay, well, I'm being multiplied by a fraction. I can solve it by multiplying by my reciprocal. On the left side, all I have left is x. On the right, I have 120 divided by 5, which should look familiar from right here. And we're going to get to 24. And again, once we got to this step right here, this 5x over 12, we could have said, well, that's the same as 5 over 12 times x and multiply by the reciprocal, which is what we did here. Or we could have divided by 5 over 12 as well, but when we divide fractions, we multiply by the reciprocal. So again, two ways to work with equations that have fractions. One, we can clear the fractions, get rid of them. We see fractions, instead of panicking, we just get rid of them. Okay, we clear them out. The second way is to just work with our fractions as they are. Use our rules for adding and subtracting, multiplying, dividing fractions, and go from there. So here, we can go ahead and clear our fractions. So right now, I'm going to find the common multiple, least common multiple of 5 and 4. 5 is just 5 and 1 for factors, 4 is 2 and 2. Since I have no common factors, I have a 5 as my factor, a 2 as my factor, and a 2 as my factor. I multiply them together to get 20. And that's going to be my common denominator, my common multiple. I'm going to multiply every single term by that least common multiple. And remember, these are all over 1. Here I'm going to get 40b, 20 times 2, b over 5, plus 20 times 3 is 60b over 4 equals 60. Reduce if we can. 40 divided by 5 is just 8b. 60 divided by 4 is 15b equals 60. Now we can combine like terms. No more fractions, no more reason to panic. Left side is as simple as we can get it, and so is our right. Right now I have multiplication. I'm going to divide to get rid of it. And b is just going to be 60 over 23. And again, if you're not comfortable with that least common multiple, we also could have cleared these one by one. I could have multiplied everything by a 4 first or a 5. So I could have multiplied by 5, which would have given me 10b over 5 plus 15b over 4 equals 15. 10 divided by 5 is 2b. I can't reduce my middle fraction, so I'm going to have to do it again. To get rid of my division, I multiply. And again, we do that to every single piece. And because I'm changing the whole equation, it's just a 4. 8b plus 60b over 4 equals 60. 60 divided by 4 gives me 15b. So I get to the exact same spot I did with my least common multiple. It's just an extra step, which is okay. It still gets us to where we're going. So if you're not comfortable with that least common multiple, you can clear them individually. Same idea here. I have 3 separate fractions. I'm going to go ahead and clear them. 9 is 3 times 3, so I'm going to list my factors there. 6 is 2 times 3, so I put a 3 in my 3 column and make a 2 column. And 3 is just a 3. It's prime. So here I have one factor of 3, and it happens to be in all my terms. That's fine. I have a second 3 factor and a 2 factor. So my least common denominator, or least common multiple, is going to be 18. If I multiply by 18 all the way through here, it's going to let me clear my fractions. So 18 divided by 9 equals 90 divided by 6 minus 18m over 3. And remember, whole numbers are over 1, and with fractions we multiply straight across. Reduce if you can. 18 divided by 9 is just 2. 90 divided by 6 is 15. And 18 divided by 3 is 6m. Now, no more fractions, no more reason to panic. My m is being added with a 15, this is a positive 15, and multiplied by a negative 6. So I get rid of my addition by subtracting 15. That's how I get to 0 there, and that's what I want. I want 0 and then just my term with my variable. So I get negative 13 equals, bring the sign down with our number. Now I have multiplication, I get rid of it by dividing, and I get m equals positive 13 over 6. Negative divided by a negative gives me a positive. Again, we could have cleared each one of those fractions individually if you wanted to, or we can find our least common multiple by finding all of our prime factors that are in our values. I have a common 3. I have an extra 3 from my 9 and an extra 2 from my 6. So when I multiply those together, I get 18. We multiply each individual term on both sides by 18 over 1. It's a whole number. Reduce and solve. We can also clear decimals from an equation. This isn't as helpful because we can use calculators or just line up our decimal points, whereas working with fractions, there's a lot more work to them sometimes. So if you don't want to clear your decimals, that's fine, but we sure can. And we do that by finding the greatest number of digits to the right of the decimal point, so after our decimal, and multiplying by 10 raised to that power. So here, after my decimal, I have 1 digit. Here, after my decimal, I have 2. And after my decimal, I have 2. The greatest number of digits then is 2. So I take 10 squared, which is actually just 100. It's 1 and then however many digits, that many zeros. And I take that 100 and I multiply it to every single term on both sides of my equation. I get 350 minus 2x equals 124. And now I have no more decimals, we can just go ahead and solve. I get rid of my positive 350 by subtracting 350. That gets me to 0. Whatever I do to one side, I do to both. Bring down what we have. Here, bigger minus smaller. Sorry, 226. And because my 350 is negative, it's a negative 226. I'm multiplying, so I get rid of it by dividing. And I get x equals positive 113. And again, we could have gotten there without clearing our decimal. So either way, whatever you're most comfortable with. Feel free to pause here and give this a try. Counting digits past my decimal, I have 1, 3, and 2. 3 is the most, so I'm going to take 10 cubed or just 1 with 3 zeros after it. I'm going to multiply that to every term on both sides of my equation. I'm going to get 500x minus 2,325 equals 3,950. To get x by itself, first I'm going to add 2325. Same signs here, so I go ahead and add them up right away. Now, I get rid of my multiplication by dividing. I get 12.55. And again, we'd have gotten to the same place if we worked with our decimals versus our whole numbers after we cleared them, so it really doesn't matter here. Clearing fractions a lot of times is helpful. Clearing decimals is kind of just a preference. Quick recap here. Equivalent equations are equations that have the same solutions. The solution of a multi-step equation can be found using the properties of equality in real numbers and inverse operations to form a series of simpler equations. And the properties of equality in real numbers can be used repeatedly to isolate the variable. That's all I have for section 2.3.